Guys, so for problem number 3, I have this done out in your notes, so I figured we would just take a second to talk about it and then look at the got it. So we have all three things going on here. We have a horizontal shift happening, we have a vertical shift happening, we have a compression factor going on, and that compression factor is negative, so we know that's actually going to reflect us over the x-axis. So my negative 1/2 compression factor takes my parent function, flips it, and brings it closer to the x-axis. All my values are going to be half as far away from the x-axis as they were before. We can see here out at x equal to 4, my y was going to be equal to 2 because radical 4, square root of that, or square root of 4 is 2. But when we multiply that by a negative 1/2, we actually just end up with a negative 1 for the y value. The minus 3 is going to shift us to the right, because remember that horizontal shift is always counterintuitive. And then we move our graph up 1, since this plus 1 is outside of the radical. And the blue graph here is actually the final model of that function. So you can see here the red one was just applying the compression factor, and the blue applies the compression factor and both of the shifts. Now look at the got it. Figure out what the graph of this would look like. Either graph it in Desmos or use your graphing utility to graph it, and then try to just sketch a graph on your paper. It doesn't have to be perfect, but just sketch, especially where is the new origin going to be, and based off this compression factor, how's that graph going to look. So take a second, pause the video, make that happen. I'm going to hop over into Desmos and do that. So I need to go ahead and put an A in front of here for my compression factor. So my compression factor was 3, so we can see that expands my graph out. My h now was x plus 2, so I actually need to make my h minus 2, because minus a negative, remember that. And then my k was negative 4, so I'll slide my k to be a negative 4, which is going to shift me vertically. And this should be the final graph of that value. Compared to the parent function, I could add another graph. I forget how to do that in Desmos, but we could add another graph here and compare it to the parent function if we wanted to. Or I can show you that right in here. If I go all the way to the end, it does not compare it to the parent function. But there we go, same graph you see here. We are almost running through the origin point. Looks very close there. Again, come back on the next video for part 4.